Stoichiometry involving gases is an essential part of chemistry that brings together concepts of pressure, volume, and temperature. But what ties it all together? The ideal gas law and understanding the molar volume at standard temperature and pressure, or STP. Today we'll explore how these principles help convert between moles and volume in reactions involving gases. For more resources and practice problems, visit King of the Curve at kotc.org. Let's get started. First, let's talk about the ideal gas law. PV is equal to nRT. This equation relates the pressure, P, volume, V, and temperature, T, of an ideal gas to the number of moles, N, and the gas constant, R. It's the foundation for many gas-related stoichiometric calculations. This law assumes an ideal gas where particles have negligible volume and no intermolecular forces. While real gases deviate under certain conditions, it's a powerful approximation for most stoichiometric problems. STP, or standard temperature and pressure, is defined as 0 degrees C, 273 K, and 1 atmosphere, ice 1 atm, of pressure. At these conditions, 1 mole of an ideal gas occupies 22.4 liters. This conversion factor is incredibly useful for quick calculations involving the volume of gases in reactions. It lets you easily switch between moles and volume when working at STP. Let's apply the ideal gas law to a problem. Suppose you have 5 moles of oxygen gas at 1 atm and 300 K. What's the volume? With this approach, we find that the volume of 5 moles of oxygen gas at 1 atm and 300 K is approximately 123.15 liters. At STP, converting between moles and volume is straightforward. Let's look at the combustion of methane. CH4 plus 2O2, CO2 plus 2H2O. If you need to know the volume of oxygen required to react with 1 mole of methane at STP, use the stoichiometric ratio from the balanced equation. Since 1 mole of methane reacts with 2 moles of oxygen, that's 44.8 liters of oxygen gas at STP. Now let's try a practice problem. How many liters of CO2 are produced at STP from the combustion of 2 moles of methane? So 2 moles of methane produce 44.8 liters of carbon dioxide at STP. What if you're not at STP? This is where the ideal gas law shines. Use PV-nRT to solve for any unknown when conditions deviate from standard temperature and pressure. Here are some practical tips. Always convert temperature to Kelvin, ensure your units are consistent, and use the appropriate value for R. These small details can make a big difference. Avoid common mistakes like using Celsius instead of Kelvin or mixing up units for pressure and volume. Always double-check your calculations to prevent errors. Understanding stoichiometry involving gases is not just for exams. It's used in real-world applications like calculating fuel requirements in engines and chemical manufacturing. Mastering these concepts opens doors to practical and professional chemistry. By mastering stoichiometry involving gases and the ideal gas law, you can confidently tackle any problem, from classroom questions to real-world challenges. For more practice problems, detailed explanations, and study tools, visit kotc.org and explore resources from King of the Curve. Keep practicing, stay curious, and excel in your chemistry journey. Thanks for watching, and happy studying.